In this lesson, we'll introduce the IRR and the XIRR functions as we discuss rate of return analysis. Rate of return analysis is the third technique we're going to discuss that can be used to solve capital budgeting problems. And so the internal rate of return, or the IRR, is the discount rate that makes the net present value of all cash flows from a project equal to zero. In some sense, the way to think about the IRR is that it's the annualized return for a given project, okay? And generally speaking, we prefer projects that have a higher IRR. In Excel, there's a function, the IRR function, that once you give the cash flow values, it returns this discount rate, okay? A few more things on the IRR. Okay, so the IRR will have different interpretations depending on the form of the cash flows. And so for investment streams where first we invest money, so there's a negative cash outlay, and then this is followed by a switch so that we have positive inflows, okay, the IRR it's called the rate of return on the investment. Whereas when we borrow, or when we have a borrowing stream where first we receive some positive inflows, positive cash flows, and then we switch to paying them off, so there are cash outlays, the IRR is called the rate of cost or the rate of financing. So in the first case, where we have an investment, we want a high rate of return. We want a high IRR. Okay, whereas when we are borrowing and we have to pay back the money, we want a low return. We want a low IRR. There are actually two functions that we can use to calculate the internal rate of return. One is the IRR function, and with this function, you give the values and then a guess, and I'll talk about what the guess means in just a little bit. And this is going to be the function to use when the cash flows are laid out kind of in a tabular format in Excel. When we have regular cash flows, so we have an annuity where we have an initial investment or a loan amount, then we can use the rate function. And in the rate function, as we have used before, we have the number of periods, the payment, the present value, and then we can put in a future value, and then we have an option to guess. And this is because for both of these, sometimes there are multiple routes, right? There are multiple discount rates that actually set the NPV to zero. And we'll talk more about that in a subsequent lesson, okay? When you have, whenever these functions return a num, it means that it tried to find the rate of return, but it couldn't converge on a value. And you will see how, for these calculations, sometimes the functions are highly nonlinear, and so it may not be able to find the internal rate of return. So let me actually show you how to do this with an example. In this first example, we have what's called an investment stream, okay? And so what this means is that we are making an investment and then getting returns in the subsequent years from this investment. To calculate the rate of return, we're going to use the IRR function and give it the transaction values. And so here we get that the IRR is 7.71%. And so we know that for any rate that is below the IRR, the NPV is going to be positive, okay? And so if we calculate the NPV here with an interest rate of 5% and then give it the values starting in period 1 and then adding the cash flow at time 0, we're going to get a positive NPV. Note that if we set this to be equal to the IRR, we're going to get, as by definition, an NPV of 0. So now let's actually discuss what an investment stream looks like. And it doesn't have to just have one investment, right? You can have multiple periods where you have investment cash flows, and then you switch, and then you have returns thereafter. And so what's important here is that there's only one switch here. Okay, we invest some money and then we get returns from it. And if we were to plot the net present value as a function of the interest rate, okay, what we would find if you just have this one switch from negative to positive is that there is a unique IRR, a unique interest rate that makes the NPV equal to 0. And so we can use this information to help us decide whether a project is viable or not. And so we know that if the interest rate is below the IRR, then we're going to say that the project is viable. And what this means is that when the interest rate is lower than the IRR, it means that the returns from the project exceed what we would get if we invested the money at a rate of VAR. In other words, we could not match the cash flows from the project, the returns from the project, if we invested this money at a rate of VAR. And so for that reason, if we have the rule, if our interest rate is less than the IRR, we're going to say the project is viable. But if the interest rate is higher than the IRR, we're going to say the project is not viable, right? Because if we're getting a higher rate of return, we could invest this money and then exceed the returns from the project. So now let's consider another example. And so here we're going to call this a borrowing stream. And with a borrowing stream, basically I'm going to get, it's like a loan. I'm going to get some money, and then in subsequent periods, I'm going to make payments on that loan. And so if I calculate the IRR here, okay, and give it the cash flows, the IRR is going to be the same, okay, but the interpretation is going to be different. And so if I calculate the NPV at this rate and then give it the cash flows starting in year 1 and then adding the cash flow at time 0, I'm going to get that the NPV is negative. So let's talk about what this means. Okay, so with a borrowing stream, again, we receive some cash flow, so there's some inlay, and then we have to make payments or outlays thereafter. So just one switch once again from positive to negative. Okay, and if we plot the present value as a function of the interest rate, again, the IRR is going to be the rate in which the net present value equals to 0. And with this observation, we're going to say that if R is less, if the discount rate that we use is less than the IRR, we're going to say the project is not viable. Okay, and the reason for this is that when the discount rate is very low, okay, or lower than the IRR, it means that the future cash flows are not discounted sufficiently to make the loan worthwhile. Okay, but if the R, our discount rate, is higher than the rate of return, then we're discounting these cash flows sufficiently to make the net present value of the loan positive. So let's go back to Excel here. And so I just want you to see that if I have, an interest rate of 10%, then here I'm sufficiently discounting the future cash flows to make the present value, making this loan worthwhile. But if I have just a, say, 2% interest rate, okay, then I'm not discounting these sufficiently, and so having this money up front is not worthwhile. The opposite is true here where I have an investment stream, right? Because it says if I were to invest $45,000 at 2%, okay, these cash flows have give me a higher return than I could get if I just invested this money at 2%. I could not recreate these cash disbursements investing this money at 2%. Just to make sure that this is clear, okay, supposing I had $45,000, okay, so what I know is that if I invested this money, okay, at 2%, I would have, at the end of 1 year, I would have $45,900, right? But what I want to see is, could I take this money out and still end with a zero balance? And so if I were to say I made now 2%, could I take out $10,000? And sure, and that would leave me with $35,900. In the next year, okay, if I were to earn the interest rate on the $35,900 and took out $13,000, the account would be left with a balance of $23,618. Okay, if I did that in the subsequent year, my balance now would be down to $13,090, and then if I again did it again for the fourth year, I would be down to $3,300. Notice that now I'm no longer going to be able to earn enough in interest to be able to withdraw the $12,000, and I'm going to be short. And so what this is saying is that if I have $45,000 to invest, okay, and in this project, and the interest rate that I can get is 2%, I should do the project because I cannot match these cash flows. Notice that on the other hand, if a bank was paying me 10%, okay, not only if I invested the 45,000, not only would I be able to kind of replace these cash flows, but I would end up at the end of the fifth year with $4,200 in the bank. And notice that if the interest rate was exactly the IRR, I would basically, invest the money, get the exact cash flows from the investment stream, and end with zero. Okay, so that's what's underlying here our decisions to, say that a project is viable versus saying that it's not viable. And so IRR is used widely, okay, by different organizations. And what is nice about it is that the IRR doesn't depend on external rates, right? It only depends on the cash flow of the project itself. And so there's a study that looked at there are different capital budgeting techniques, and we've talked about just the internal rate of return and the net present value. And then we also looked at the annual cash flow analysis. But what this table shows is that the vast majority of companies, over 3/4, use internal rate of return and net present value to assess the viability of projects. And it's used more frequently by larger firms than by smaller firms, because often smaller firms have other constraints that may drive project selection. But with larger firms, they almost always use one of these, and they're somewhat interchangeable. And so, as I said before, if there's only one sign change, then the IRR is going to exist and it's going to be unique, okay? But when you have multiple sign changes, then, basically, the IRR is basically the roots of this function, and it can have multiple IRRs that make the NPV equal to zero, and then the interpretation becomes more complex. I actually want to do a couple more examples to highlight this. But before I do that, I want to talk about the XIRR function, okay, which is analogous to the XNPV. So when you have a ledger, okay, then you can give it, where the periods are not equally spaced, then you can give it the values, okay, and then the dates, and then the XIRR function will give you the rate of return for that project. And then finally, as I said before, we can use, when we have uniform or regular cash flows, we can use the rate function. So here we have a project where we have an initial cash outlay of $17,000. We then have we receive $16,000, and then we have a cash outlay of $59,000. And so here we actually can have multiple, more than one IRR, because we don't have just one sign change. We have one and then two sign changes. And so I want to show you what that means and why we might need a guess. And so if we do IRR and then we give just these cash flows, okay, we're going to get an IRR of 17.07%. Okay, and when we look at the NPV here, okay, with our discount rate, and then we give our cash flow starting at year 1, and then we add the cash flow from year 0, we get kind of a negative NPV. Okay, and so this means that this project at 10% is not worthwhile. And so what has happened here, right? Because we had said we can't really make the inferences that we made when we had just an investment stream or a borrowing stream, because this doesn't quite hold. And so here we can use the NPV to help us decide. If we wanted to use the rate function, okay, the rate function has to have uniform payments throughout the horizon. And so before I do that, I want you to recognize that as I drew this cash flow to make it uniform, I said that I'm going to get 16,000 in each of the 5 periods. And so I can write this as minus 17,000, a uniform series of 16, and then a cash flow of 75. But when I add a minus 75 plus 16, I get the negative 59 that I'm seeing here. Okay, so if I wanted to use the rate function, I would say rate. Okay, there are 5 periods in my horizon. I'm going to have payments of, I'm going to get payments of 16,000. The present value is we had to invest 17,000. Okay, and then we have a future value of minus 75,000. Okay, and when I do that, I also get the same IRR. I think it's important to see, and I did this using just a one variable data table. I used the rate, and then I calculated based on the rate the NPV for these cash flows. And what you can see is that when I plot this, I have 2 places where the 2 rates in which the NPV is equal to 0. And one of them is around 17, which is what we found, but there is this other one here that is around 60. And so when we're running the IRR or the NPV, we can say, give me, my guess is 0.60, and it's going to return to me. This is type. Actually, I want a type of 0, and then I want a guess of 0.60, and it's going to return to me this second rate of return. And so sometimes we want to do this because we have a specific rate of return, that we have a particular interest rate, and we want to find an IRR that's closest to that, so that we can make this comparison with the NPV. And so that's what the guess is there for.